I'm going to talk a little bit here about solving an equation for a particular variable. And that's sometimes what we're asked to do in a particular problem. And so when we're solving an equation for a particular variable, there's sort of really two things we need to think about. Usually we just think, well, it means get the variable by itself. Well, what does that really mean? The first thing that's really important is the variable can really only be on one side of the equation to solve for it. It's not good enough to just get it by itself and have it on the other side. For instance, if you look at here on the bottom, you could say, well, let's say I'm trying to solve for x. Well, I could just move this b. I could subtract b from both sides, and then I could divide by a. All right? So I could come down here and I could say, all right, I'm going to subtract b from both sides. That's going to give me ax equals cx plus d minus b. And then I could just say, all right, well, now I'm just going to divide by a. Because then these a's are going to cancel out. And I'd be left with x equals cx plus d minus b over a. And you'd say, okay, I'm done. The problem is now you're saying what x is equal to, but you're saying x is equal to something involving x. So you really haven't solved for x there. And so that's not good enough. So we have to get that. Let me get rid of all this. That's wrong. Okay. So let's get rid of that. So up here, that's why it's important first that the variable can only be on one side of the equation. What we can also say then is we're trying to isolate the variable. Get the variable alone by itself. It can't be in two places to be isolated. So typically these are steps that we're going to follow. These are what your author lists in the textbook. I've changed it around a little bit. Some of it's the same. Certainly, typically we want to get rid of any fractions first using the lowest common denominator, just like when we're solving rational equations. We also typically want to get rid of any parentheses, although not necessarily. I'm going to look at an example where it's almost easier to do the problem not removing the parentheses. This is what the author said, but these aren't lockstep. You don't have to do these steps in exactly this order, and there's sort of an art to this. You need to look at the problem and think, how am I going to get the variable by itself? Certainly, if you have any like terms that you can combine, we can do that to sort of clean up each side separately. Now, if the variable you're solving for is only in one term, it's in only one term, then it's pretty easy getting it by itself. That's usually the kinds of problems we've done earlier in the course. What's going to be new here is some of the time the variable we're solving for is going to be in more than one term. The little trick we're going to do here then is we're going to get all the terms involving the variable on one side of the equation, but the other terms, okay, the other terms on the other side. Then we're going to be able to factor out the variable as a common factor and divide to get it by itself. So let's imagine we've done the steps and we get to this equation that we looked at earlier. I don't want to just subtract the b. So I want to get the stuff involving x. I'm trying to solve for x. And what I see here is, I've got x in a couple places. So I want to get everything involving x on one side. Let's bring everything with x over to the left. So I'm going to get rid of this cx. So I'm going to have to subtract that from both sides. So that's going to give me ax minus cx plus b equals d. So it says get all the terms involving the variable on one side. That's what we've done here. Everything involving x is on one side. But then we have to get all the other terms on the other side. So this b doesn't have an x. That means it has to go over to the other side. So I'm going to subtract b from both sides. So that's going to give me ax minus cx equals d minus b. And let me just rewrite that here. Ax minus cx equals d minus b. And this now is where this little trick works. Since we got everything with x on one side and this is only stuff involving x, we notice that we've got x in both terms. That means I can think of that x as a common factor. So I can play what's missing. X times what equals ax, I would need an a. X times what is negative cx, I would need a negative c. And now, if I want to get x by itself, I can divide by that whole quantity a minus c. What that does here then, a minus c goes into itself once and once. And so I'm left with x equals d minus b over a minus c. And that would be the solution. So when you're solving an equation for a variable, we try to get the variable on one side all by itself. Sometimes we have to use this type of procedure to make that happen.